Hello everyone. We're going to finish this video or finish this topic off, the circles on the coordinate plane, with this final video. And this time, all of the problems that we're using, we're going to actually either utilize the graph as a part of our solution, or as given as a part of the problem, or we'll utilize it to help us get to the solution. So all of this has to deal with graphing. We're going to write the equation of this circle, and the information is given to us on the coordinate plane. So we have a picture of a circle, and in order to write the equation of the circle, the same two pieces of information are needed. Basically, we need the center of the circle and we need the radius. Now, we can look at this picture and come up with the center. The center is at the point. If we count over, it's at 5, -2. And then the radius is the distance from the center of the circle to the side of the circle. So the best way to go about doing this is to count in a horizontal or horizontal manner. By vertical, I mean either up from the center or down from the center, and then horizontally is either left or right. If I look here, I count exactly to the right. It'll give me that the radius is 2. And the reason why that is the best way to do it is because generally the radii that you will see will be whole numbers, and so you can count on the whole blocks of the circle. So it's just easiest to find or what the radius is in that way. So now we have the two important pieces of information, and we can write the equation of our circle in parentheses x minus 5 squared plus y. This is a -2, so +2 minus a negative give you +2. A squared will equal r squared. Remember that r squared is what we'll need, so this will in fact be 4. That is our first example using the coordinate plane there. All right, let's clear this out and try a second example working the other way around, where we're going to be given the equation and we're actually going to graph it. I need to include the graph paper again, so never mind that overlap that you just saw. Alright, let's go ahead now and take the equation. Let's suppose we have an equation, x plus 1 squared plus y minus 1 squared equals 36. We're going to draw this circle on the coordinate plane given the actual equation of the circle in standard form. So the same two important pieces of information, the center and the radius, are what we need. The center is at -1, +1. Right, we know to go opposite signs from what we see because the form has negative in it. And the radius is the square root of 36, which is just 6. And we know that with the square root, you do typically have positive and negative. But in geometry, we will reject that negative value in most cases because we don't want negative lengths. All right, so the radius is 6. The center is at -1, 1. And now I can place this on my coordinate plane. Let's go ahead and do that. At -1, 1, here is the center. And then I'm going to do the exact same thing that I just taught you in the last example, which is that I can count vertically and horizontally from the center to get my points on the circle. Because 6 is a whole number, it's easy to count horizontally and vertical. So 1, 2, 3, 4, 5, 6. There goes 1 point on the circle. 1, 2, 3, 4, 5, 6. There's another point. 1, 2, 3, 4, 5, 6. Another point. And the fourth one. 1, 2, 3, 4, 5, 6. There we go. So it should kind of appear to be like a target type thing where if you can imagine the circle being drawn, it's like an outer circle and this inner point there, which is your center. And I'm actually going to sketch my circle freehand, just as you'll have to do it. Now, the way that I sketch freehand is I try to just connect one arc at the time. You have a total of 4 arcs that you'll need to connect because of the 4 points that you just graphed on your circle. So, as you can see, I'm trying to get the smoothest arc that I can possibly get. Alright, it's not perfect, but I try to get the smoothest arc that I can get on every side. I don't try to do the whole circle at one time. One arc at the time. And If you don't like something, just take your eraser and go at it again. And I've got one more arc here that I've got to finish up. Alright, so there's my circle. Alright, on an exam or something, I would accept something like this. It's not perfect, but it's reasonable form of what I'm looking for. I'd actually take another color here and see just how close I was. I can use this perfect circle stencil that they give us there. So you can see it was pretty close. I have a little green coming from underneath of the circle, but there you have it. That is a circle on the coordinate plane. Okay, so we've graphed the circle. If you want to write here, oops. No, because I didn't write the directions there. We graphed it. We graphed it. Very good. All right, let's go ahead to our final example. This last example, I'm going to use the coordinate plane. All right. I'm going to use it, but it's not necessary for it to be there. I'm using it just to show you how it is used or how I'm coming up with this reasoning to answer the question. Again, we're going to write the equation of the circle. Okay, we're writing the equation of the circle. I'm going to write it again, but this time I'm going to have different information. They gave us that the center was at 7, -2, and instead of giving us a radius, that's what we're used to, they're going to give us a point on that circle, -1, -6. So I have one thing that I need, but I don't have, I have the center, I need that, but I don't have the radius. And so that's what I'm going to need to be able to figure out. Let's start off by just coming up with 7, -2, seeing where that's at. So 1, 2, 3, 4, 5, 6, 7, -2. That's the center. And this point, -1, -6, is right here. That's on the circle. So if you can imagine just what this circle looks like, it would be bigger than this graph paper that I have, but it would go something like this, around this center. It would go way out and about, something like that. Big, big circle, right? That kind of looks more like an oval, but anyways, just to give you an idea of what would be going on here. And we're missing the radius. Notice that I can form a radius just by connecting the center and the point that's given to me. So that distance from the center to the point is the radius, and that's what we'll need to find. So we can do that just by using the distance formula. So our radius that we need, which is the distance that we'll need, will be, put my square root, 7 minus a -1, so that becomes +1 squared, plus, let's do our y's, -2 minus a -6 squared, so minus a negative became a positive there as well. So r will equal the square root of 7 plus 1 is 8 squared, -2 plus 6 is 4 squared. R will equal the square root of 64 plus 16, and r is the square root of 80. Now, in terms of the equation of the circle, I actually need r squared. So let's just go ahead and square both sides. R squared, if I square this, the square will undo the square root, their inverse operations, and get that r squared is 80. Now let's write the equation of this circle. So the equation of the circle is x minus 7 squared. Take note that I'm careful to pick the center and not the point. This is the first time where you have kind of 2 points up there. And by point, I mean the point on the circle as opposed to the point that's in the center. That's the point that I need, is the center of the circle. So you don't want to make that mistake. So x minus 7 squared plus, and that's a -2. So we'll do y plus 2 squared will equal r squared, which is 80. There you have it. That is the equation of the circle. All right. I'll see you in another lesson.